Hi everyone, welcome back to our Python memory management series. In the first videos, we covered how Python manages memory and how reference counting works. Today we are diving into garbage collection thresholds, the numbers that control when Python cleans up your memory. And of course, by the end of this video, you'll understand what those mysterious numbers actually mean, how Python's generational garbage collection works, when and why might want you tune these settings, and importantly, how these defaults have changed in recent Python versions. Let's get started. Alright, let's start by actually seeing these thresholds. Open up your Python interpreter. First, let's import the garbage collector module with sys. And let's see what Python version we are using. Now here is something interesting. If you are using Python 3.12 or earlier, you will probably see something like 71010. But if you are on Python 3.13 or 3.14, the Pi, you might see 201010 or even higher. Why the change? The Python core developers found that 700 was triggering garbage collection too frequently for modern applications. They bumped it up to reduce overhead. This is a perfect example of how Python evolves based on real-world usage. Important note: these numbers can change between Python versions. Always check your specific version and don't hard-code assumptions about these values in production code. Let me explain what these three numbers actually mean. The three thresholds represent three generations: threshold 0, threshold 1, threshold 2. Generation 0 is like young objects, short-lived. Generation 1 is middle-aged objects. And generation 2, old objects, long-lived. Think of it like this. Imagine you are organizing your closet. Generation 0 is like the chair where you throw your clothes you just wore. You check it every day, high frequency. The threshold of 700 or 2000 in newer versions means when 700 new objects are created, check generation 0 for garbage. Generation 1 is like your dresser. You check it less often, maybe once a week. The threshold of 10 means after 10 generation 0 collections, check generation 1. And finally, generation 2 is like your storage boxes in the attic. You rarely check them. After 10 generation 1 collections, check generation 2. Alright, now that we understand the basics, let's see what GC get count actually does in practice. And trust me, this is where things get really interesting. Let's start with a fresh Python session. We'll import the GS module and check our starting counts. As you see, we got 194, 3, and 0. Now here is a critical thing to understand. These are not the number of objects in memory. Let me say that again. These are activity counters, allocations counters, not object counts. A lot of people think this tuple tells you how many objects are in each generation. That's wrong. What it actually shows is allocation activity. Think of it like a pedometer. It's counting steps, not telling you where you are. Let's break down what these numbers mean. 194 means there have been 194 allocations since last generation 0 collection. 3 means Gen 0 has been collected 3 times since the last generation 1 collection. 0 means generation 1 has been collected 0 times since the last generation 2 collection. And remember, those thresholds. In most Python versions, generation 0 triggers at 700 allocations, generation 1 at 10 generation 0 collections, and generation 2 at 10 generation 1 collections. Okay, now let's create some objects and watch what happens to that first number. Here we go. Boom! 194 jumped to 288. That's about 94 new locations recorded. Actually, there has been like 100 new locations and 6 new day locations, and of course we got 94. But wait, let's think about what we actually created here. We made one outer list called myList, and then we created 100 inner lists. Each inner list contains the same integer repeated 100 times. Now here is a fun Python optimization. If you remember, small integers from -5 to 256 are actually cached. So when we do I multiply by 100, we are not creating 100 new integer objects, we are creating 100 references to the same cached integer. Pretty clever, right? Pretty clever, sorry. So we are mainly allocating list objects, not thousands of integers. Here is what the memory structure actually looked like. Our myList variable at the top, pointing down to all those inner lists, which reference cached integers. Everything connected, nothing orphaned, nothing collectible. Okay, here comes the moment of truth. Let's manually trigger a generation 0 collection and see what happens. 0 objects collected. This confuses a lot of people. We just created 100 plus objects, the counter went up by 94, and now the garbage collector says it collected nothing? Here is what most people expect. The garbage collector should clean up all those objects we just made, right? Wrong. The garbage collector only removes unreachable objects. And guess what? Everything we created is still reachable. We have a variable called myList pointing to our outer list, which has references to all 100 inner lists. Every single one of those objects is reachable from our code. The garbage collector can't touch them. The garbage truck came by, looked around, and said, "Nothing to collect here, boss. Everything is connected to something." But look at what did happen to our counters. Generation 0 went from 288 to 0. Generation 1 went from 3 to 4. This is the key insight. Even though 0 objects were freed, the counters still updated. Why? Because Generation Collect 0 does 3 things every time. It tries to collect Generation 0 garbage, found none this time. It resets Generation 0 counter to 0, and it increments the Generation 1 counter. The counter reset happens regardless of whether any garbage was actually found. Think of the Generation 0 counter like an hourglass. Sand falls into it with every allocation. It fills up, fills up, fills up, and when it reaches the threshold, flip. The generation garbage runs and the hourglass resets. It doesn't matter if the garbage collector actually threw anything away, the hourglass flips anyway. The counter resets anyway. Let's have a look at our animation. As you see, when our generation 0 reaches the threshold, 700 in this case, it resets to 0 and increases the generation 1 by 1. And finally, when our generation 1 reaches the threshold, in this case 10, it increases the generation 2 by 1 and resets to 0. We can even try to speed up to see things even faster. So let's nail down the key concepts here. Garbage collection get count returns activity counters, not object counts. For that, we can use get objects. Garbage collector .collect method only frees unreachable objects, things with no references. Counters reset even when 0 objects are collected. Reference counting handles most cleanup, but circle references need garbage collection. The generation 0 counter steadily increases until it hits the threshold, then resets. And that is how getCount method really works in practice. Those numbers aren't telling you what's in memory, they are telling you what Python's been up to since the last cleanup cycle. I hope this video was useful for you. You can like and subscribe. And thanks for watching.